Okay, sorry for the disturbance. So this is about the return statement. Okay, that is the function returns a value, then you need to include this return statement at the end of the function or the method definition. So otherwise include void. So void represents nothing. Okay, it never returns any value. So that is the return statement. So this one. So this is int compute int n comma m. So this represents the function is going to return an integer value. The function is going to return an integer value. Okay, that is int k equal to n star m. Then return k. This k is integer type, so that it is going to return an integer value. Then you need to include this int return type in front of this function name. Okay, this is the simple example. So this is going to return one integer value. Okay, it is going to return one integer value. Okay, so this is the simple example which is I'm going to be illustrated. Okay, this is about the function declaration. And next one is another important concept about these methods is the overloaded methods. Another important concept of these methods is the overloaded methods. So what is overloading? We know the concept of polymorphism. Okay, the concept of polymorphism we know. So what is polymorphism? We know. So poly represents many. Poly represents many, and morphism means forms. Morphism means forms. This is one of the object-oriented programming concept we know. Okay, one of the object-oriented programming concept known as the polymorphism. So polymorphism means many forms. That is the ability to take more than one form. Ability to take more than one form is known as polymorphism. Okay. So coming to this polymorphism, there are two types of polymorphisms. Okay. There are two types of polymorphisms. So one is a runtime polymorphism, and another one is the compile time polymorphism. One is runtime polymorphism. Another one is the compile time polymorphism. That is the polymorphic behavior of a particular method is known at the time of the either compile time or at the time of the runtime. That is known as the polymorphism, compile time or runtime polymorphisms. Okay. So for example, if you can take a method draw, there is a method called draw. Using this draw method, you can draw different shapes. You can draw different shapes like a rectangle you can draw, and like a circle you can draw, and you can draw a square. Okay, so it depends upon the parameters passed. You can draw different shapes using the same method. Okay, now this form of overloading is comes under this compile time polymorphism. Moreover, it is known as a overloading method. Overloading of the methods. So what is the overloading of methods? Using the same method name, you can use. Here the method name is shape, that is draw. Now the same method is used to draw different shapes here. One is the rectangle, another one is circle, another one is the square. So using the same method, you can draw different shapes. So this is one form of compile time polymorphism. Okay. So another form is there, runtime polymorphism. That's what we'll see later. There is a concept called dynamic method dispatch. There is a dynamic concept called dynamic method dispatch. So there we'll discuss about this. What is this? Runtime polymorphism. That is the runtime polymorphism means which version of the method we are going to invoke is not known until the runtime or until the time of the call. So that is called runtime polymorphism. This is second part we'll see. So now the compile time polymorphism in Java, one of the best example is the overloading of the methods. Overloading refers to using the same method name here, suppose. That is called method overloading. Using the same method name to perform different operations at different instances. Different operations at different instances. Now, how a compiler or how a Java runtime system is came to know the implementation of the methods. That is, even though the name of the method is same, that is with method overloading, the method name is same, methods with the same name and scope are permitted provided they have different signatures. This is the important point you have to note here. It have different signatures. Different signature means different headers of the methods. How they will differ? Either the number of parameters, they will differ in the number of parameters or types of parameters or their order of the parameter list. Their order in the parameter list. Now the two different methods should differ either of these three categories. Either the two different methods must be differentiated in the number of parameters or the types of the parameters or the order of their parameter list. Okay. So number of parameters, that is if one method takes one integer and second method takes two integers and another method takes three integers. If the type is same, suppose all types of the parameters are same. Now both are integers. Suppose the type is integers. Now one method takes one integer, another method takes two integers, another method takes three integers. Okay. So like that, the two different methods will be differ either in the number of parameters. Next one is the types of the parameters. Suppose one parameter is integer and another parameter may be float. That is one method takes all integers, another method should take all floating point numbers. Three integers, three floating point numbers. Okay. So that is the types of the parameters and their order of the parameter list. Suppose it is int float. One method takes int float, another method takes float int, another method takes float int. This is the order of the parameters. Here both the data types are int float, but here first method takes int float, second method takes float int. That is their order in the parameter list is also important. Order is also important. This is about the method overloading of methods. So this is the thing what we have discussed till now. Now the first one is the first option takes int compute. Now it takes two integers, integer n comma integer m. Okay. So it takes only two integers. What is its return type? Integer, and the method name is compute, and here it takes two integers, int m comma int n. There are two parameters of type integer here. Two parameters of type integer. And the next one is the method name is same compute. Method name is same compute. Its return type is also integer. Both are same, but it is different in number of parameters and types of parameters. So here double n and int m double x. Now it takes three different arguments. There are three different arguments. So one is of type double, another one is of type integer, third one is of type double again. So two double variables and one integer variable. So this is second implementation, second version of the method compute. And the third version of the compute method is again return type is integer. Return type is integer. So here it is integer, supposed to be, it is a double. You should write double here actually. So it is wrongly marked as int. It is the double data type. So here it is the return type is suppose void. It is wrongly written as integer. Suppose it is void. The method name is again compute. The method name is compute, and it takes only one integer. Okay, only one parameter. Okay, so that there are three different methods with the same name. Three different methods with the same name, but their implementations are different. Okay, so let us see one example here. Overloaded demo. Very overloaded demo. So this is one method here. Okay, its method name is my method. Name of the method is my method. First version, first implementation takes no parameters. Okay, method without parameter here, but the return type is void. Now all the four implementations takes void data type. Five implementations takes void data type. That is nothing returns. So the default implementation, that is there are no arguments here. The method takes no arguments. The next one is it takes only one argument. My method int n. It takes only one parameter. And the implementation is int n, int m. There are two parameters of type integer here. There are two parameters of type integer. Next version of this method takes three parameters. There are three parameters of type integer, int n, int m, int p. Okay, and the next version double y. There are two parameters of type double. There are two parameters of type double. It is going to print its division. Okay, so these are the three different methods. These are the three different methods. These are the different implementations of the overloaded method called my method. There are five implementations of the area. There are five variants of the method. So the first variant, no arguments, one argument, two arguments of typing. Without any parameters. And the second implementation takes only one parameter of type integer. Pass one integer value, and next one pass two integer values. Pass two integer values and pass three integer values. And last one is the pass two different double values. Pass two different double values. Okay. Now suppose if you want to compile this, then Java C ex dot Java, then Java ex. So now this is the first one, no return type. This is what we have written here, no return type. And next one is n equal to 5, because we have passed n equal to 5 here. And third one is the n star m with two different parameters, n star m. This is 21 into 2, that is 42. And next third one is n star m star p, three integers, 5, 3, 2, that is 5 into 3, 15 plus 2, 30. You will get 30. And next 12.6 divided by 2.0, then you will get 6.3 as a result. Okay, so this is known as the overloading of methods. This is called overloading of methods. Okay. So this is a simple example that illustrates overloading of the methods. This is the example we have seen just now. Okay. So next, another important point related to this methods is sometimes you can also pass objects as parameters in the methods. Objects as parameters in the methods. Now earlier example, suppose there is a method called swap. So here int x comma int y. Now where x and y are the ordinary variables. Where x and y are the ordinary variables here. Okay. They are ordinary variable. Sometimes, for example, there is a class FARM. There is a class called form. Then the class may take object of the same class as argument sometimes. Okay, object of the same class. That is form itself, it is a class, suppose. Okay, form itself is a class. Now, suppose there is a class called area. There is a method known as area. Or you can also write constructor form. Or this area method takes the form class object form F as argument. Form F as argument. So that is called object class objects as parameters in its methods. That is an object of a class may also be a parameter of a method. Okay, this is form is a class. This is object of this form class is passed as a parameter in a method. Okay, that is called an object of a class. Also maybe a parameter of a method. Now the type of an object. What is its data type? Suppose F is the object, where F is the parameter. What is its data type? Its data type is same as the class name. Data type is same as its class name. What is its class form? So this form class acts as a data type and F acts as a variable. F acts as a variable. So that is the type of an object of a particular class is the name of its class. This type represents data type. Okay. Now the operations that the class object may be subjected to are the ones derived from the class object and those defined in its own class and the superclass if it is the object of the derived class. Suppose a form is the derived class, then it has operations of both its own plus what are the members available in its own as well as its superclass also, as well as its superclass also. Okay. So this is the point number 3 pertaining to class objects as parameters. Okay, class objects as parameters. So this is about what are various parameters in a class. Okay, and how to pass object of the class as a parameter. Okay, for example, this is the form class. Now it has two variables. One is the length, and the other one is the width, and one constructor to set the value of this length and width. And one method is there called equals. This is the method known as the equals. Now equals is a method. It takes one argument. What is the argument here? Form. What is this form? Form is the object of the form class. Object of the form class as argument. Okay. Now in its definition, form dot length star form dot width is equal to length star width. Now both are pointing the same objects, same variables, length and width. Okay, if both are same, then returns true, otherwise it returns false. Okay, now when you are invoking this method, equals method, what you have to do is create object for this form class FARM. Form F equal to new form, form F equal to new form, then invoke the method with the help of the object f dot. What is the method name? Equals. Method name is equals of f. What is f? Again, this f and this f both are same. This is object actually. Just we are invoking object of the class f. Okay, using the object of the class f, that is f dot equals of f. What is this f? This f is passed as argument to the method this one. Now this is going to represent the object f with two variables. What are the variables? One is the length variable, another one is the width variable. Anyhow, both are representing the same, so that it is going to return true for this example. It is going to return true for the example. Okay. So this is the process of passing objects as arguments into the methods. Okay. So this is about what is a method. So we have discussed about what is a method and what are different types of methods, and how to pass parameters to a method. That is the signature of the method or the header of the method and the body of the method, and what are different types of parameters, and what is meant by method overloading. Okay, and how to implement method overloading, and next one is passing objects as parameters, passing objects as arguments to a method. So this is what we have discussed in today's class. So in the tomorrow's class, we will see what is a recursive method and what is the use of the keywords native and transient. Okay, so that part we will discuss in the next class. Okay, so thank you.